This is differentiation in dimensional analysis. So we can still use application of differentiation when it comes to dimensional analysis. So after the first video that I share, I received messages that is dimensional analysis is this just all about dimensional analysis? No, we can still use application dimensional derivation in dimensional analysis for the benefit of those that are writing GEE exam. That is the joint exam for those that want to study any engineering course in country like India. So we still have the relation aspect of dimensional analysis. So let's look at this question. The relative error in determination of surface area of a sphere is alpha. The relative error in determination of its volume is dash. So we are given the relative error. One is to that of the area of the sphere, which give alpha. We want to find that of the what, that of its volume. So there are three keywords here that we need to take note of. The first one is one, the relative error. Two is the surface area of the sphere, and respectively as well the volume of the sphere. So what do you reverse to as relative error? Relative error is the measure of accuracy of how the measurement is compared to the what, to the truth value. So that's what by what, by relative error. And talking about a sphere is something that is spherical in what, in shape, while half of the sphere is reversed to as hemisphere. So here we have the surface area of the sphere and likewise the volume of the sphere. So we have been given the relative error to that of area, which is alpha. We want to find that of what, that of its volume. So we should remember that the area of a sphere is what, is 4 pi r square, while the volume of the sphere is 4 over 3 pi r cube. So this is the area and volume of the sphere respectively. Here now, you know that the relative error to that of the area is given as alpha. We want to find relative error when it comes to its what, when it comes to its volume. So here now we move down to the area here, that is our A is equals to 4 pi r squared. So when we differentiate this, we're not differentiating this A with respect to r, we differentiate this on separately. To differentiate this, we are going to take the log of both sides. So when you take log of both sides, so this will give you, that will be what, that will be the length of A is equals to the length of what, of 4 pi r squared. Do you know that I can see how this one to become the length of A is equals to the length of 4 pi plus the length of r squared. I think you should know what I mean by this. That is, we remember from the rule of indices, this can still give us the length of, so this one, so far is additions, we can multiply it, that is what, 4 pi what, r squared. So this is still reversed to as what, as this. So having have this now, the next thing is that from log, so we're going to have this one to become what, to become the length of A is equals to the length of 4 pi plus 2 length what, 2 length of what, of r. So the next one is that we now differentiate this. That is, when you differentiate this, we are going to differentiate this. When you do that, when you differentiate your length of A, it's going to give you the A over A. So when you differentiate the length of 4 pi, don't forget that the derivative of the constant value is 0. So this 4 pi here is a constant value because the equation is in terms of A and what, A and R. So this one will give us 0 plus. So the length of R will give us 1 over R. So this one will give us 2 di R over what, over R. So this one will give us what? It will give us di A over A is equals to 2 di R over what, over R. So now when you multiply it, you divide, since di A over A here is equals to 2 di R over R, and di A over A here is representing the relative error for the surface area of the sphere. So I will replace this di A over A by R, because R in the question is denoted by what, by relative area of the what, of the sphere. This one will be replaced by alpha, that is alpha is equals to 2 di R over R. So I want to get by R over R. So I have to divide through here by 2, divide through here by 2. I will have alpha over 2 is equals to di R over R. So now I want to get relative error in its volume. So, and you should recall that the volume of a sphere is what, is V is equals to 4 over 3 pi r cube. So this one as well, I'm going to take the log of this also. I'm going to have the length of V is equals to the length of 4 over 3 pi plus 3 ln what, 3 ln r. So if I differentiate this, I'm going to have that V over V is equals to, so far this one is a constant value, and the derivative of the constant value is what, is 0. You're going to have 0 plus derivative of Ln of r is what will give us, the derivative of this will give us what, 1 over r. This one will give us, will give 3 di r over r. So here now, this one will give us di v over v is equals to 3 di r over r. And what is di r over r? Di r over r is what is alpha over 2. So I'm bringing this here to replace the r over r. So that is the v over v will give 3 multiplied by alpha over 2. So that is 3 alpha over 2. So the relative error in its volume that will be very close to the truth value is what is 3 alpha over 2. What of the area is what is ordinary alpha. So you can practice all these questions. Likewise, the background of the video as well is full of questions based on dimensional analysis. So you can practice this as well. And when you find any question challenges, right, you can send a message to the email, or probably you can comment below under the video. So we are going to attend to your question.